Does anybody actually go back and listen to the recordings by chance? Does anybody find them helpful sometimes?
They help me go to sleep.
Really? Gosh,
I put them on at night.
you do not. I was gonna say. All right, here we go. Bell work day 4. Wow, that is not showing up there. That's kind of weird. At the very top. So Jamie is planning to bring only a carry-on for her trip to London this summer. She plans to bring 5 shirts, 3 pairs of shorts, and 3 pairs of shoes. How many possible outfits can she make? First of all, let me ask you, is this a probability? Jason, is this a probability? No, it is not a probability. That is not what we asked you, but that is important to remember, okay? Joels, what do you think? 45 outfits. And how did you get that?
5 times 3 times 3.
Okay, so you took your number of shirts, which was 5, times the number of shorts, which was 3, times the number of shoes, which was 3. 5 times 3 is 15. 15 times 3 is 45. How many had 45 out in our studio audience here? Yes! If you didn't, remember, and for those of you that were not here yesterday, it's just the total number of each. Oh, it's not even showing. Nobody even told me that. Why is this not showing? Oh, come on. Where's my little thing? Why is it not showing? See, it's right here. Right there. Doesn't matter if it's not showing for you guys. Oh, I know why. Okay. Okay, there it is. I know why. All right. So, 45 outfits. All right. Any questions about number 1? Number 2, use the table to answer the following questions. What is the probability that someone purchased soda from the concession stand? What is the probability that someone selected soda from the concession stand?
200 out of 400.
Wait. What?
This is the part that I was having trouble with my homework yesterday. I tried to do it, but then I had one struggling, so that's what might need help.
Okay. So somebody said,
200 over 400.
okay, 200 out of 400, and somebody else reduced it to?
400.
Right. Okay, whoever's got a podcast or something on, please turn it off. All right, so soda. When it is just one item, you look at the soda total out of the total. And what is my total? The bottom right-hand corner. Make sure it's got total over here and total over here. They join together at 400. And yes, you could simplify that to 1/2, but you wouldn't have to. And let me tell you something. I was looking at the skills check on Friday. We tell you, do not simplify. Okay? So if we tell you not to simplify, don't reduce it. Just leave it over 400, okay?
What do we do?
You'll probably miss half a point for not following directions. That's why I'm bringing it up to you now. Okay? All right, letter B. What's the probability that someone selected that combination? First of all, is that an and statement or an or statement? It's and. That looks like a small n. So it's pizza and water. Say it quickly and it seems like and. That's how I kind of remember it.
58 over 40.
Pizza and water means it has to happen at the same time. That is an intersection. Okay, so here's pizza, here's water, and they happen at the same time. At the intersection is 58 over our total of 400. That is correct. Anybody happen to have that answer? Okay, how can I help you? Oh, you had it? Good. Okay. If you didn't get it, how can I help you? What can I do to help you understand that more? Pizza and water at the same time, an intersection.
Pizza and water. Can you gotta, I didn't get it, so I understand it. Can you kind of go through it again? So I understand?
Well, pizza, you look at pizza, and that's an and. Think of it as an N. If you say it quick, pizza and water. It's an and statement. You have to have both at the same time. So make a line for your pizza, make a line for your water. Where they cross at the same time, that's going to be your numerator, 58 over 400. Okay?
And this is in soda. How did you get it?
Huh?
Oh, they're right there.
Okay.
How did you get 400?
How'd I get what?
Oh, all right, I got it.
Yeah, it's in the bottom. Unfortunately, it's like right there.
All right, keep two.
There we go. All right, and the last one for this one. The probability, if the one before was and, this is an or statement. Or. We're for the union. We want everyone to join. You're going to be so sick and tired of me saying that, aren't you? Yes. So the probability that someone got a hot dog plus the probability that someone got a soda minus the probability that someone got a hot dog and a soda at the last time. At the same time. Wow. So, probability of a hot dog. Okay. Find your hot dog. It's in the first row. Go all the way to the end to the total. That's 158. We know it's going to be over 400. Plus the probability that people selected soda is 200. So plus 200. We want everybody. We're for the union of everyone. Union means joining together. Minus those who got a hot dog and soda at the same time. So find out where they intersected. Here's soda and hot dog. So minus 50. And doing my math up here, I got 158 plus 200 is 358 minus the 50 should give you 308 over 400. Okay? Any questions about that? All right, and again, I am recording this. I'm going to upload it. You can watch it. You can fast forward. You can slow it down where you need to hear it or listen again. All right, let's now turn to your notes. We are talking about a new topic today, permutations and combinations. How many of you think you have ever heard of that? Permutations, combinations? Yes. Yeah. Okay. Hang on just a minute. I think we are on, I don't have the right page number. 14, thank you. Page 14. Let me do this one definition and then I'll get you, okay? So, permutations versus combinations. But first, we're going to talk about a factorial. A factorial is something like this. We say n factorial. So n is going to be some number, and then we put an exclamation mark. Okay? Page 14. So what this means is you are going to multiply n, whatever your n value is, times all the natural counting numbers below it. Which basically means you are counting down to the number 1. I'll explain what that means in just a minute. So n factorial means you start with n, whatever that number is, and you multiply it times all the natural counting numbers. Now, when you start counting, you count 1, 2, 3, 4, 5, right? But here we're going to go in reverse order. So let's say I had, let's go to letter A, 5 factorial. Okay? So we start with 5, and then we multiply and go down by one number each time. So that means 5 times 4 times 3 times 2 times 1. That's what it means. Okay? And then we just multiply those together and say 5 times 4 is 20. I can do 3 times 2 is 6. And 20 times 6 is 120. Okay? While I am writing a pass, I want you to try and see if you can come up with 9 factorial. Okay? 9 factorial. So start with 9. Multiply times each of the numbers that are 1 less each time all the way down to 1. You go, Bjorn. Guys, come on, put the phones away. You guys multiply it all out? You did? Okay, so 9 factorial would be 9 times, everybody say it with me, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you multiply backwards from that top number all the way down. Multiply all these, and what did you get, Jewels? Whoever's got the music on, please turn it off. Don't be rude.
I got 140.
You got what?
140.
You were multiplying?
Oh, no, I added it on.
Oh, we don't add. You need to multiply.
I did, bro. I did 9 times 8, 72, stuff like that.
Right.
72 plus.
Not plus. Got to multiply everything.
So it's not 72 plus 42.
Oh no, it's 72 times. That little dot means multiply. Times 42. Times 5 times 4, which is 20. Times 3 times 2, which is 6. Does anybody got an answer? What'd you get, Micah?
362,880.
362,880. Anybody else get that? All right. So let me show you, because we don't want to have to multiply that stuff, do we? We do? No, we don't want to have to do that. Let me show you something. Pick up your calculator, and I'm going to show you a shortcut. A shortcut. And I need to come back here to do that. So on your calculators, I hope this works. I'm going to have to go off here, and I think, where is this? Here we go. There we go. All right, so look on your calculators. I wish I should have had one. So you should see, first of all, you are going to select whatever number they give you factorial, you're going to select that first. So choose 9, okay? Then right here, it looks like on mine, it's the second row, second column, it says PRB. That stands for probability. So you're going to select probability, and you're going to see this, okay? Now, if you look down, line number 3, see that exclamation point? That is the factorial button. So you press the down key twice, so you get the factorial. Then you select enter, because that's the one we want. And there's 9 factorial. And press enter again. 362,880. Yes, right? We like that. All right, you want me to go over it again one more time? Well, let's do it with 13. So we know what it means. All right, so clear this, hit clear. Everybody make sure you're doing this with me, okay? You first start with the number. So 1, 3, that's 13. Then you go to probability, second row, second column. That gives you these choices. Put the down arrow twice to get to the third line. Hit select or enter. That gives you 13 factorial. And what did you guys get? You know, it's probably a really large number.
Yes, 6.
Ooh, yes, let's see. And they don't put commas in here. It is 6 billion. So 6 comma 227 million, that's a comma, 20,000 comma 800. 6 billion 227 million 20,800. It's gonna look like this. Okay, so 13 factorial. Again, you press 1, 3, then you hit probability, PRB, PRB. Then you hit the down arrow twice, okay, to select the third line. Hit enter, enter. To select the factorial, that's going to give you 13 factorial. I think you hit enter again, and that should give you that answer. 6,227,020,800, which is a lot easier than multiplying 13 times 12 times 11 times 10 times 9, blah, blah, blah. All right. Any questions about that? Okay. I'm going to stay back here because we're going to be on the calculator again here very soon. Let's talk about permutations. Permutations. What is a permutation? It is an arrangement without replacement. Without replacement. And the important thing is that order matters. That's all in caps for me. Order matters. Okay? So an arrangement without replacement, like if I am pulling out marbles from a bag, I am not going to pull out the marbles that I took out and put them back in the bag. I'm keeping them out. That's what it means when I say without replacement. So here's what it looks like. we usually have an N right here for N number of objects. That's your total number of objects you have, your total. And this is the R, so they call it NPR. And the R means you're taking R number of objects at a time. R number of objects at a time. And here's what I want you to remember. This is a little mnemonic device. I want you to think of pom-poms. Pom-poms means for permutations, order, that's the O from the poms, matter. Order matters. Pom-poms, permutations, order matters. Okay? Combination is very similar. That's why some people have a big difficulty with it. Combinations is an arrangement. An arrangement with replacement. And order does not matter. Order does not matter. And it's going to look the same as our permutations, except instead of the P, we have a C. So we have N over here, and that is, again, N number of objects. That's the total number of objects we have. And then we have an R, and we are taking R number of objects at a time. Maybe I'll say R number of objects at a time. So permutation, pom-poms, order matters. Permutation, order matters. Combination, order does not matter, and it is with replacement. So if I take out a marble, that first marble, I'm putting back in the bag. That's what it means. Okay? All right, so let's just do some basics here. I'm going to give you a couple of numbers. I'm going to give you 10 permutation of 10 taken, let's say, 3 at a time. We're going to figure out that one. Then let's compare it to a combination of 10 items taken 3 at a time. See what the different numbers are.
Is that an N or
N. N. Those are N. Okay, so do you remember how when we went to the probability? I'm going to put it up on the screen now. 10, 3. I need to remember that. So I'm going to take this off. I'm going to bring up the calculator. See if I can do this again. All right, so on your calculator, we need to come up with the first number. If you remember, permutation, it was a permutation of 10 objects taken 3 at a time. So put the 10 in first. Your total number of objects goes in first. Okay, then select probability, which is second row, second column, the PRB button. Notice it is line number 1, NPR. So hit enter right there. It gives you the 10 NPR. We said taking 3 at a time, so select 3 and press enter. And we get 720. 720. So put that down for an answer. Nope, that's not what I wanted. So right here, 10 permutations at 3 at a time is 720. That's the answer. Now, let's see what it is for a combination. Okay, so let's go back. Hit clear if you haven't already. So this is a combination of 10 items. You always have to start with your total number of items. Good morning. Then go to probability. Okay, hit the down arrow so you get to line 2. That's a combination. Hit select or hit enter. And we want 3 at a time for the combination. Hit enter again. And that answer is 120, which is very different. Okay, so let me bring this back up if I can. So right here, this number is 120. Okay. For those of you that are a little bit more mathy, I'm going to tell you what these mean and how they got those numbers. But we're going to be using the formulas on the calculator. So a permutation of 10 items taken 3 at a time. Jeremiah, come on. Is you start with 10 and you put the first 3 numbers. So 10 times 9 times 8. 9 times 8 is 72. 72 is times 10 is 720. So that's what you're doing mathematically. But your calculator is going to do it for you. Okay? For a combination of 10 items, you start the same way. It's 10 items taken 3 at a time. Whoops, that should be an 8. And then you divide it by the 3 factorial, which is 3 times 2. This ends up being 720 divided by 6, which gives you the 120. So mathematically, that's what you do. But for most of us, we are just going to use the calculator. Okay? All right. How much time do we have? I am going to give you 2 more examples. See if you can find some space. And I just want you to do these. See if you can get the correct answer on your own. Let's do a permutation. A permutation, just add it kind of somewhere in there, of, let's say, 8 items taken 4 at a time. See if you can do that on your calculator. And let's see if you can do a combination of, let's say, 13 items taken 10 at a time. See if you can do those 2 on your calculators. Permutation of 8 items taken 4 at a time. Combination of 13 taken 10 at a time. Okay? Let's see if you can do those. And let's see if I can take this off. Presentation hold. Maybe not. No, that's not what I want. Okay, fine. Guess I'm gonna have to do this. So, calculators, 8. Permutation of 8 taken 4 at a time. You start with the total number, 8. Hit your probability button. We want the permutation, so we hit enter. Taken 4 at a time. What did you guys get for an answer? Anybody? Say it again. 1,680. That looks good. 1680. 1680. All right, and then the second one was a combination of 13 items. So start with 13, hit the probability button. We want the combination, so go down. Jeremiah, you should be watching. Hit the down arrow so you get the combination, hit enter. Taken 10 at a time, and you should have gotten 286. 286. Okay? 286. Any questions on what we covered today? So we talked about factorials. There's a factorial button. We talked about permutation, pom-poms, order matters. And we talked about combinations. Combinations. An arrangement with replacement, order does not matter. Any questions at all? All right, so your homework tonight is to get started on, let's see, it is 7-2. 7-2. So if you go to Canvas and you go to modules right over here on the side, everybody take a look at the Promethean board. Go to modules, select modules, find today's date, Tuesday, April 25th, permutations versus combinations. You're going to come up to this. You go down to the bottom. Here's where I'm going to put the video up at the top. Here is the bell work in case you missed it, the notes, and right here is your homework. You click on that link and it's going to take you right to it. So now most of you have homework number 1 that you need to start. And here's homework number 2. This is due on Friday. Due on Friday. Okay? So we are done with the notes for today. Tomorrow we will work on those problems that are left in our notes. And you'll probably have a little bit of time to work on homework tomorrow. But everybody, let's get started on that first homework. You have 5 attempts to get 100%. 5 attempts, okay? All right, good class today. Keep looking over those notes again.